Okay, today we're going to be looking at the properties of some common three-dimensional shapes, common since the times of the ancient Greeks and the ancient Egyptians. This shape up here in particular is a square-based pyramid, which is exactly what the Great Pyramid of Giza is. So these shapes are very, very common. Of course, most skyscrapers are essentially a cuboid stood on end. But we're going to be looking at three properties in particular of these three-dimensional shapes that you do need to know for your exams and you need to be able to tell apart. So, the three properties are faces, edges, and vertices. So what are they? Well, a face is the two-dimensional surface that faces you. So in this cube, this face is a square. In this triangular prism, the face that faces me is this triangle. This face on the right-hand side is a rectangle. So it's the ones that you could reach out with the palm of your hand and touch. An edge is like this one up here. It's like running your finger along the edge of a knife. Don't do that. It is the straight length, the line that is the end that joins faces. So we were saying before this is a triangle and this is a rectangle. Well, joining two faces are edges. So each face is joined by an edge. And lastly, vertices. Those are the points, the corners, the one-dimensional points that join the edges. A way of remembering that is in the word vertices, the V in vertex looks like a little corner, a little point, which is exactly what it is. It's a vertex, a point. So we're going to count these up and in particular pay close attention to the cone, the sphere and the cylinder, which we'll come to last, because the curved nature of those often confuses people. So we'll start with the linear shapes, the rectangular pyramid, just like Giza. Well, what are the number of faces? Well, if we count them, we have the one that faces us, the one at the back, the one at the left, the one at the right, there's 4, and then underneath what it's resting on, there's 5. So there's 5 faces. Edges is 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. And vertices, 1, 2, 3, 4, and 5 at the point right at the top. 5, 8, 5. Next we'll do the cube. Number of faces, well, it's the same as the number of sides on a dice. It's 6. One at the front, one at the back, one at the top, one at the bottom, one at the left, one at the right. 6 faces. Edges, be careful that you don't miss any that are behind in the shape. 1, 2, 3, 4 coming out the page. 5, 6, 7, 8 on the front. 9, 10, 11, 12 on the back. 12 edges. And the number of vertices, 1, 2, 3, 4. At the front, 5, 6, 7, 8. At the back, we've got 8 vertices in total. And the triangular prism, we'll start with the number of faces again. We've got the front and the back. There's 2. This one gets a little bit trickier to visualize. You've got this rectangle on the right here, there's 3. You've also got that rectangle on the left at the back there, there's 4. And you've got the base that it rests on. So there's 5 faces. Number of edges, well, we have the obvious 1, 2, 3 at the front from the triangle and the 1, 2, 3 at the back, so there's 6. You've also got the 1, 2, 3 going into the page, making a grand total of 9 edges. And the number of vertices, 1, 2, 3, 4, 5, 6. So there we have 5, 9, and 6. Now, to the ones that have some curved surfaces, here's where it gets a little bit trickier. If we look at this cone here, the number of faces, we've got this obvious one on the bottom, but this curved edge around the whole cone, like an ice cream cone, that is just one face. It curves around, so the number of faces is just 2. Edges can also be confusing here. What are my edges? Many people might think there's this curved edge at the bottom that you could run your finger along, which is true, that's one edge, and then they might look at the shape and say, well, this is another edge there, and that's another edge on the right there. That's not true, that's just a trick of perspective. If you ran your hand around there, it would be smooth, there's no edges there at all. The only one edge is that one that you could run your finger along and it would feel sharp along the bottom. That's one edge. And vertices, that's that point right at the top, 2, 1, 1. What about the cylinder? Well, we have one curved edge, faces first. We have that one curved face all the way around. We have the face at the top and the face at the bottom. So we have 3 faces. We have, in terms of edges, this curved edge at the top, this curved edge that I could run my finger along and it would feel sharp at the bottom, and these 2 at the sides are not edges. They just look like edges. If you imagine moving your hand around a 3-dimensional cylinder, like a tin of beans, it's smooth all the way around. So we have 2 edges, one at the top and one at the bottom. And what about the number of vertices? Well, do you see any points? No, that's because there aren't any. No corners, no vertices. And finally, the sphere, the strangest one. Number of faces in a sphere. Well, if imagine you run your hand across a perfectly spherical ball, do you feel any edges? No, you do not. There is only one continuous face. Of course, there are no edges, so the number of edges is 0. And are there any points on a sphere? No, none at all. One face, no edges, and no vertices. Okay. Now, we're going to move on to just see some exam questions of this and see how they are applied. So, here is an exam question. You have to, given this solid, find the number of faces and find the number of vertices. So, let's approach this carefully in an exam situation. You're given these dashed lines at the back. That's your ability to see behind the shape as well as see the front. It's often a good idea to use your pen and then mark the faces so that you know, right in the middle, so that you know that you've not missed any. So this face at the front, we'll put a nice big mark there. That's 1. There's 1 at the top, 2. 1 at the right, 3. Are there any missing? Yes, there are. There's this shape here, this rectangle, which makes up the base at the very bottom. That's also 1 that we missed. And then we've got this rectangle on the left there, dot in the middle of that. There's the other one. So what do we have in total? 1, 2, 3, 4, 5. And are there any we've missed? Yes, there are. There's this trapezium shape right at the back. Put a dot there. So in grand total, we have 6 faces for this shape. Again, that little hint, putting the dot right in the middle, can often be very useful. And because it's in the middle, you're not going to confuse it with any of the other dots. Now, what about the number of vertices? A bit easier, this one. Just check all the points where the edges meet. Do it in a different color. We have 1, 2, 3, 4, 5, 6, 7, and 8. So that's 8 vertices in total. So that would be your marks for that question. One for you guys in the comment section. What is the name of this 3-dimensional shape? I'll give you a hint. It is not a trapezium or a 3D trapezium. There is a special mathematical name for it. Does anyone know? If you do know, put it in the comment section. If you'd like to get in touch with myself, my name is Adam, tutor for Sherpa, or any other Sherpa tutor, I'm sure they can let you know the answer as well. Okay. Have a good day, guys. Enjoy.